Hi, welcome to QuBites, your bite-sized pieces of quantum computing. My name is Rene from Valorem Reply, and today we're going to talk about quantum security and all the benefits that quantum mechanics are offering to our security infrastructure. And I'm very honored to have a special expert guest today, Lea Jäntgen. And you might remember her from a previous episode where we talked about all the threats that quantum computing is, basically putting on as our security infrastructure. But today we're going to talk about how you can actually take advantage of quantum computing and quantum mechanics for your security infrastructure. Because you can have both sides, kind of, right? Hi, Lea, and welcome to the show. How are you today?
Yeah. Hi, Rene. Yeah, thank you. I'm good.
Awesome.
I'm really good.
Can you tell us a little bit about yourself and your background as it relates to quantum computing and security?
Yeah, sure. So I'm working here in Germany for Spike Reply. We are doing the IT security for Germany. And my background is actually in business informatics, and I really like to combine the security topics with business topics. And quantum computing, I'm part of the COP, the Community of Practice at Reply. And yeah, I like to combine all these three things and see what cool things are there in the future for us.
Well, that's a perfect match for our show here. Business, quantum, and security, the triangle. That's awesome. So let's dive right into the topic. What is actually quantum security all about?
Yeah. So when we talk about quantum security, we actually talk about two sides of a coin. So one is, as I mentioned in the last episode, which threats are there to quantum to security by quantum computing. So what do I have to prepare for? What can I expect? What's the uncertainty, the risk here? The other side is, how can we use quantum computing to maybe make our security stronger and better? Mm-hmm. And this is what we want to talk about today, I believe, more.
Yeah, absolutely. And so what kind of benefits can quantum computing actually provide via applied quantum mechanics? Like, how can you take advantage of basically the laws of our nature at a smallest dimension, right? So how can you use that actually for security and cryptography and key transmission and that kind of stuff?
Yeah, so quantum computing in general is a new tool that we have, right? So we can implement new algorithms, for example, new encryption algorithms based on quantum computing principles. But we can also use it in a way that we make, for example, key distribution safe, or that we can detect man-in-the-middle attacks, which is a very hard topic in current security, that we don't know really man-in-the-middle attacks. So quantum key distribution actually works via a fiber cable, a quantum secure channel, basically a physical channel. And you can detect a man in the middle inside this channel because of the way quantum computing works. The photons get changed if somebody looks at them in the middle. So once we have implemented this channel, we know that there might be a man in the middle, and we can use this channel to make, for example, symmetric encryption and make the key distribution. And we are certain that the key is not intervened, so there's no man in the middle.
Awesome.
So and if there is one, we can just try again, the new key exchange.
So could you describe it as like a read once key exchange, kind of? Because like once you read it and like a man in the middle would read it out, they would change it, right? And so yeah, on the receiving side, you would know about it. So you can only read it once, basically, at the receiving side, right?
Yeah, exactly. So and otherwise the state of the photons would change. And I know at the receiving side, oh, this is not what I expected. There must be somebody in the middle. So I tell my other person to send me a new key. Awesome. Until we know that there was no one in the middle.
That totally makes sense. I mean, that's some of the basics quantum mechanics, and it's pretty awesome that you can apply it. Do you know if this is actually currently already applied, and can you share some examples of like some real world use cases you have seen out there?
Yeah, sure. So I'm focusing here more on a European market. There are some examples in the US as well, I know. There are a lot of trials by universities and governments. For governments, it's, for example, good, you could do secure elections via this. Or for telecommunications, it's really cool because you can ensure that the communication is safe. So there are a lot of trials there that that are being built. So one example is in Italy. They wanna they laid a cable through all of Italy to actually test out how well this is working. In the UK, they also did that in London, which is called UK QN. I believe QN stands for Quantum Network. The Italian ones call it Quantum Backbone of their company. And the idea is to actually enlarge this over all of Europe so that you have these quantum secure channels in all of Europe. So far, it's not used in a very productive state. It's more used by researchers and by universities to see what can we do in the future with it. So as I mentioned, telecommunications, governance, and universities, these are the most people that research on this topic at the moment.
Awesome. Well, that makes a lot of sense. And it's great that there's like a public infrastructure being built, which we could probably then tie into for, private services or other kind of things that can be done. Thank you so much, Lea. We're already at the end of the show. We could talk for more hours, and maybe we'll have you at some of the next episodes as well. Thanks so much for joining us today, sharing your insights. Very much appreciated.
Yeah, thank you.
And thanks everyone for joining us today for another episode of QuBites, your bite-sized pieces of quantum computing. Watch our blog and our social media channels to know all about future episodes and when we post them. Take care, stay safe, and see you soon. Bye-bye.